Okay, good evening, everybody. Good evening, everybody. Uh, Welcome to our class for those who attend for the first time. Last week, we just have like a scan of the course outline. We talk about assignments, quizzes. There is no midterm or final exam in this course. As I mentioned in the previous class, all accommodation, those for who need special time or extra time to do their exam, it will be considered in the quiz time. For example, if the quiz need 10 minutes or 15 minutes, I'll make it 35 to 40 minutes. So at that time, everybody has more than 100% of the original required time of that quiz. However, as I mentioned that both quizzes or assignment that will be checked by Turnitin, even the term paper and the group presentation will be checked by the Turnitin for plagiarism. So your work should be original. That's why I repeat this to be in recording. I received some email from some students asking about the recording of last week's class. I recorded, but due to the size, it was 40-minute video or 35 to 40 minutes video. Due to size, it will be difficult to upload it to OWL. That's why I start working in a YouTube channel. I create the YouTube channel. I put the first video. I'm just finalizing the setting and the quality. So maximum by tomorrow or this weekend, all videos of first class, today class, and tomorrow's class will be added as links in OWL, so everybody can go to the YouTube and watch the video if his situation didn't allow him to attend the class. Also, last week, I asked students to revise their mathematical background in the set theory. And today we will touch base again with this thing. I'll give you the first activity for today's class. There are some questions in the handout that you need to answer. I will send the link. I will send the link for a Google Sheet to paste or to paste your answers. It could be a PDF or a Word in a Google Drive folder. I will share the link with all of you. So guys, let's start. By the way, for those who just recently joined us, that all the classes will be recorded. So we give the chance for those people, because we know there are some students, they are overseas in their home countries and they attend. So due to the time difference, some of them will find difficult to attend these classes. For example, I'm currently in Jordan for a family case. So the time now is 12:30 a.m. in the morning. So some people, they are in China, they are in India, they are in some other countries. So with them, it's very early morning there. So due to this time, I understand. That's why I'm not taking attendance. The attendance will not be a factor that affect your mark, because we put these videos so you can attend the class later on. If you have any question, guys, as I mentioned, that every Wednesday from 4 to 5, there is an office hour. I will be available through Zoom meeting. I will be available through Zoom meeting. So you can just click the link. The link is available with the passcode and the course outlines. Also, I will add it to OWL, or I think I added to OWL. I added to OWL in the first page of OWL, of our course website. So our first handout, it has an introduction and it will start with deterministic finite automata. So course introduction, I didn't change anything in the handout. Since this course was delivered by Professor Essex. However, for the last 2 years, he was not able to teach this course due to other tasks that he have, like administrative task in the department. That's why he's not teaching this course for the time being. However, I would don't like to change anything in the course because in the future he will back to his course. So this website, I'm not sure if it's still working, but it is not. It is not working, I believe. So this course website, our course website will be OWL. The formal course website will be OWL. So what is this course about? This course will talk about theory of computation. What do we mean by theory of computation? Theory of computation is an aspiring software engineer. You can imagine it may be useful to have some understanding of the fundamental capabilities and limitation of computer and software. So computer and software cannot do anything. There are still some problems that not be solved by any computation hardware. In this course, we will explore some of the most fundamental questions of our field. What is computation? What do we mean by computation? What do you need to perform a computation? Which problem you can solve with computation? Sorry. And of the problem with solution, which are easy and which are hard. So we'll touch base with basic principles of computation, how programming languages are designed, when we design a language, like for statement, how we do it, how we think about it. When we read a string, what is needed, how we do that. So we'll touch base of these things. So this course built based on graph theory and set theory in the mathematics. However, some students find it a rigid course. We'll try to simplify everything and make sure that students are understanding every concept. Okay, guys, by the way, sometimes I receive an email that a student joined the Zoom meeting in different timing. I believe those students who are overseas, so they consider it's in local time. All times posted in course outline, in our website, in the invitation I send you via Zoom for the classes and tutorials. All of these are using London, Ontario timing, which is Eastern time. So if you are in different part or different time zone, even inside Canada, there are different time zone. So please consider the difference between London timing. So all our classes, our university is located in London, Ontario. So all our classes will follow the Eastern time, which is the time that we have in London, Ontario, our local time. So background and significance of this course. From cogs to qubits. So the computation or the theory of computation started with Charles Babbage, sorry. And if you click on the link, you will go to find more information about these persons, which dreams of a general purpose machine to perform calculation, which is literally, or the abstract of that is the calculator at the beginning they started. Inspired by the idea, his colleagues, Ada, so outlines the first software program. Between 1900s to 1930, a mathematician, David Hilbert, proposed a set of 23 greatest as of then unsolved problem in mathematics. So David identified 23 problems that still unsolved in mathematics. The second and 10th Hilbert problems eventually lead to him to proposing the problem, or what is called decision problem. So loosely speaking, the question asks whether there is an algorithmic means of deciding whether a proof exists for a given logical statement or not. And we will see some of these proofs in this course. Then Alan Turing, they propose or independently proved the no to the decision problem, introducing a universal model of computation in so doing. In 1956, Noam Chomsky described the hierarchy of formal grammars with important implication for programming languages. In 1970s, the University of Toronto professor Stephen Koch proposed the P versus NP. So we will have this by the end of the course, So this concept for P and NP, I'm not sure it will be an assignment. I believe in assignment 4 and in quiz 4. Considered one of the most important open problem in computer science today. Then in 1994, proposes to run a quantum computer that would efficiently solve the integer factorization problem, which cannot be solved before, and which would break the RSA and related public key crypto systems currently used in to secure digital communication and networking security. So worldwide, if you could build such a device, recent documents show that among the other, NSA is working hard to develop one. Guys, for this part of the course, I'll never bring you a question like in 1971, who did that, or it's a history. So it's just an introduction. If you wanna see these topics, you can easily click in the link and it will open for you a web page to tell you more about this thing if you are interested in these. Now we will start with some mathematical notation that will be our friend in solving most of the question till the end of this course. So when we said Z is the set of integer. Z is the set of integer that starts from minus infinity to positive infinity for integer. So no floating point numbers or fractions. The natural number, when we said n, so we are talking from 1, which is the positive integer number, from 1 to infinity. Set builder notation, when we said X statement, so the set of all X prime for which a statement is true. So some use like instead of some use the colon instead of the vertical line. What is X belong to Z? That means, and the condition is X greater than 0. Who can answer this question?
Is it natural numbers?
It is the natural numbers. Great. Yeah, thank you. So it is the natural number. So the natural number is a subset of integers. The natural numbers is a subset of integers. Sets. When we saying a set, so any set, it's an ordered collection of elements. When we say an order, so it could be x1, x2, x3, x4, x3, x2, x1, x4, any order, it doesn't matter. This is an important point, guys. Note it, that the set is an unordered collection. Next slides, we'll see the tuple, which is an ordered list. So there is a difference between a set and a tuple. So let A equal x1, x2, and x3, and x4, then B equal a set of x4, x5, x6. So element order, does x1, x2, x3, x4 equal x4, x3, x2, x1? Yes or no?
Yes.
Yes. So set membership. Which statement is true? X1 belong, this one means belong, this symbol. X1 belong to B. Is that true or false?
False.
Yes.
False. X1 not belong to B. True or false?
True.
True, yeah. So the second statement is the true statement. The first statement is false statement. Okay, so when we are saying subset, what do we mean by subset? Subset is a part of that set. How we know that this is a subset of a set A? That means that this element or elements are contained. This one means contain. This one belong. This one means between double quotes that it is a part of the set A or a partial part of set A. So X1 contained in A, true or false?
True.
True. The second one is the same, it's a typo. X1 contained or equal to A, is that true or false?
True.
True, yep. So X1, X2, X3, X4 contained in A. The same thing, X1, X2, X3, or X4 are contained or equal to A. Yes, it's a true because it's equal to A. So first statement, is it true or false? Which is X1, X2, X3, X4 contained in A.
I think they're both
Is it
true.
false?
Yes, it should be or equal. So the second one is true.
But the first one is false?
The first one is false, yes.
Can you explain why?
Okay, so when we said X1 is a subset of A, no, do you know what? Even this one is a subset. Yeah, all are true. All are true. All are true. But mathematically, the second one is more true than the one because it has the equal. But this one also is a subset of itself. Each set is a subset of itself. So the first statement is true. Is that clear, guys? Any question? Just unmute your mic and ask.
Can you just explain the final two parts? Like, what's the difference if you have equal or not equal?
Yeah, this one, what does that mean? That this one is a subset of A. If we talk mathematics, each set is a subset of itself. So it's true. But if you want a more accurate and more formal mathematical, so we will say it is a subset or equal A. Is that clear, guys?
Yeah.
What do we mean by a subset? A subset that it is a smaller set that can has one or all element of the same set. Is that clear?
So what just the subset could imply is that there might be more.
Yeah, so X1 is a subset of A, X1, X2 is a subset of A, X2 is each element of the set is a subset of that cell. Each two element, for example, for our example here that we have a 4 element in that set. So any combination of all of them or a single element or a couple of elements or 3 elements are a subset of that A, but it should be belong, yeah, X1, X2, X3, X4. So X5, if we put X5, it will be false. Is that clear?
Yeah, that's perfect. Thank you.
Yeah. Okay. So here there is an activity for today. A set is an unordered collection unique of elements. So let A equal X1, X2, X3, and X4. So what is the power set of all subsets? What is the power of A? Power set of A. What is the power set of A? If you need to have an information about power set, you can click this link, or for the set in general, you can click this link. I need an answer. Put it in a document, a Word file, or put your name, your number, and I will share with you tomorrow evening a link for a Google Drive so you can put your file there. Is that clear, guys? And please name the file using your name, or your name is better. Your family name or your name and family name, it doesn't matter, is better. So the file name, and in the top of the page, put your name and your ID, student ID, to answer these questions. Is that okay, guys? Because these answers, as I told you in previous class, that I will use these things to help you, because we will have 5 marks point depend on answering these activities or in-class activities. So it will be 5 marks extra to fulfill any shortage in your coursework marks. Clear, guys?
Yeah.
Okay. So I need the answer of what is the power set of A. And what do we mean when we put these, like it's not absolute value. So
It's the number of
Size,
elements.
like the size of.
size of P, yes. Great, thank you. Size of P equal 2 to the size of A. What is the answer of this question? Because all this information, guys, you get it in the previous math courses. So I need you to refresh your memory. Okay, so I need also an answer for this question. Is that clear, guys?
Sorry, so these docs, they're going to be marked, obviously, or is it?
Yeah, I will mark these. It is not mandatory. It is not. So any people who will answer these set of in-class exercises, they will have by the end of the course 5 marks extra. For example, in assignment 1, you get 9 out of 10. And in quiz 1, you get 8 out of 10. So at the end of the course, these 5 questions, these 5 marks will fulfill these any shortage in your marks.
Okay, makes sense. Thank you.
Yeah,
Is it
so
just lecture?
you're literally any student who will do all these activities, his total mark will be 105, but it's considered as out of 100. So you have 5 marks bonus. Okay, guys?
So are we supposed to answer all the questions on these slides or just the ones that you
Now,
mentioned?
the one I mentioned, So
Okay,
in this
all right.
slide number 11, so what is the power set of A? What is the size of power set, which is equal? I put the equation 2 to the size of A. So try to answer these 2 questions. We'll have more. So slide 11, the 2 questions in slide 11, this is the first activity for you guys. So as you know, and as you study in high school and in previous math courses, that we have some operations that can be carried out on the set. The first one, we call it union. So if we have A contains or equal to x1, x2, x3, and x4, and another set B which has x4, x5, x6, union of sets A union B equal any set member that where x belongs to A or x belongs to B, not and. And I'm pretty sure that everybody of you would know the difference between or and in set theory, right? So if the union is and, what is the answer of this question? A union B.
It's
X4.
just
It's everything in A and B. It's x1, x2, x3, x4.
Yeah,
x5,
but
x6.
I said if here we have the word and instead of or, what is the
It's gonna
answer?
be
x4.
4 only.
X4 only. Great, thank you. But now it will be x1, x2, x3, x4, x5, and x6. But we'll not put x4, x4. Any shared element will be mentioned 1. Okay? Okay, the intersection of sets A intersect B. That means any set member, any set element X where X belongs to A and X belongs to B. So in union, it is or. In intersection, it is and. So the answer of the question, what is A intersect B?
x4.
X4, exactly. And what is A union B? It is x1, x2, x3, x4, x5, x6. Any question, guys, till this point? Guys, just to let you know, in the next few chapters, we will have some class notes. Normally, last year I was writing in the board. I told everybody last week about this. However, I repeat this in this class. So normally I write in board and the student copied what I used to wrote. However, in this class, I will use the tablet, the pen tablet, to explain to you during the class to understand the math. But you don't need to write these things because I will write it in my handwriting and scan it and upload it to OWL to make your life easier. Is that clear? Because this will let you understand more the mathematics and the mathematical proof in the following chapters. Okay, cardinality of set, which is the size of A, the number of elements in A. What do we mean by the cardinality of A? So this symbol, it's not the absolute value that you used to see in algebra or in calculus. In set theory, this means the cardinality, or as your colleague said, it is the size. And what do we mean by the size? It is the number of elements in that set. It is the number of elements. So what is the cardinality of A?
4.
4, exactly. Is the cardinality of B greater than the cardinality of A?
No.
No. Let A equal the subset 1, 2. What is the cardinality of A? I need an answer. I need an answer in the worksheet. So slide 12, the last question is in the activity. And guys, if you click in each one of those, if you still have some ambiguity or uncertainty in this topic, you can revise it from wiki for set union, set intersection, or set cardinality. So anything you see in pink color in the handout, that means this can guide you to a web page that clarify this more, or you can refresh your mind in these topics. Okay. So there's an answer of this one. So this one considered when we have a subset, but put it in your activity. So this one, what do we mean when we have double brackets? The 1 and 2 is one element of that set. So the cardinality of A is 1. The cardinality of A is 1. Okay, so let's see equal phi. What do we mean by phi?
It's the empty set.
Empty set, exactly. So what is the cardinality of C?
So C would have a cardinality of 1 because it contains an empty set.
Yes. So the first observe, everybody will say it's 0. But in the other hand, the cardinality of C for the set phi equal 1 because C is containing the empty set. So these tricks sometimes in quizzes or in quizzes, we don't have exams. In quizzes or an assignment, sometimes will guide you to a wrong answer. So be careful in these things, okay?
So does the phi consider like one element inside?
Yeah,
the
it's
set?
considered phi is an empty set. Since we have one element of empty set, that means the cardinality is 1, not 0. Okay?
Yeah, okay.
Tuple. We will stop talking about the set. We'll talk now about tuples. A tuple is an order list of necessarily unique elements. So the same example, let A equal a tuple, not a set, of x1, x2, x3, x4, B equal x4, x5, or x6. element order does x1, x2, x3, x4 equal x4, x3, x2, x1? Yes or no?
No.
No. But if we are having the bracket of set, yes, it's equal. But in a tuple, no. Because the tuple make the differentiation, the difference, not the difference. The set is an unordered list. However, the tuple is an ordered list. So I cannot change the order of element of the tuple. However, I can do it for a set. The Cartesian product. The Cartesian product, like A multiply B, or Cartesian product of A and B, equal any tuple A, B, where A belongs to A and B belong to B. So what is a Cartesian product of B? I need an answer. Cartesian product of multiple set. If we have A, Cartesian product B, Cartesian product, etc. till Z, A, B to Z, where A small belong to A, B belong to B, Z belong to Z. A cross B, A dot B, so the same. And this is, again, this is not the absolute value symbol. This is the size of A Cartesian product B, or A times B. So what will be, in our case, the size of A Cartesian product B? I'm talking about those sets. Also, this is a question need an answer. So we have two questions. In this slide. This question and this question. Function. What do we mean by function? Function is mapping between a set of input and a set of output. And normally denoted by F colon A to B. If we input A, what are the set of result or output? A function domain is the set of possible input. When we said, what is the domain of function? So we are talking about the possible input. If we say f x to y, and we said x belongs to n. So the natural number. So what is the function domain of f? It is the natural number. A function range is the set of outputs. So there is a difference between domain and range. The domain is the possible inputs. What are the value of x? And we said the y, which is represent b. What are the range of output? And we said b belongs, for example, to real numbers. The domain is a set of b into which all the output fall. The image is the subset of b prime that belong to b of the codomain into which all elements of the domain are mapped. For example, let f equal z, which is the numbers, the integers z, and the output also is belong to z, be f of x to x prime, i.e. f of x equal x prime in math. So what is the domain? The domain is z. The image is n to number 0, for example, 0 plus the natural number. Because as you know, like when the output is squared, so we'll not have negative number, right? But 0 square is 0. So it will be the natural number adding to it the 0 for the image. Is that clear, guys? Any question?
Yeah, sir. So you said the codomain is the output, right?
Yes.
So in this function, if we're inputting integers and then those integers are squared, how's the wouldn't the codomain be the set of all natural numbers and 0?
Sorry, here is the domain. Is it? It's a
Oh,
typo. It's a typo from the Dr. Professor Estek's slides. So the domain is Z, and the image is the natural. When we need to include the 0, we put the natural number to the power 0, which means that the 0 is included.
oh, okay. Okay,
Okay.
thank you.
Sorry, you can remove these, the CO, guys. It's the domain. Multiple variables, example, for example, Z by Z, and the domain were in Z. So for example, X and Y, it will give us X squared plus Y squared. This is the function. F of X equal is X squared and Y squared. Here, it is not the symbol of sigma, guys. In set theory, that means it's an alphabet and a string. What do we mean by alphabet? It is any letter symbol or any digit. So when we said sigma, which means an alphabet equals 0 and 1, is the binary alphabet. We call it the binary alphabet. And you know that the computer at the end point will use will use the machine language. And what is the machine language? It is the binary numbering system, which is consists of 0 or 1. So what is the alphabet? A, B, C, X, Y, Z. What we call this alphabet?
It's for English, but like it could be like Dutch, German. So I guess uppercase alphabet.
Uppercase alphabet, yes. It is the uppercase alphabet. Thank you, Rachel. A string is a finite sequence of symbol of a given alphabet. When we said a string, so it's a finite sequence of symbol of a given alphabet. So we have alphabet from A capital to Z capital, or uppercase of English letters. So is password a valid string?
Yes.
Is password 1 a valid string of this alphabet?
No.
No, because we don't have digits. Is that clear, guys?
Yeah.
Okay, so let alphabet equal 0, 1, which is the binary alphabet. Is 0 a valid string?
Yes.
Is 0, 0, 0, 0, 0, 0, 0 a valid string? The second one, this one?
Yeah.
Is 0, 0 infinite times 0 a valid string?
No.
It's
No,
not.
because
They have
that's
to
be
be finite, right?
Amazing. Thank you, guys. Thank you. So this one is not a valid string. Why? Because we said it is a finite sequence of symbols. So any string should be a finite sequence of symbols. If it's infinite or infinity times, so it will not be a valid string. Alphabets and a string. The symbol epsilon denotes empty string. How phi equal empty set. In strings and alphabet, we will use the epsilon symbol, which denote empty string. It functions as identity element. Think of adding 0 or multiplying by 1. What is the size of epsilon?
Would it be 0?
No.
It's the
One.
same as the empty set.
Yes, so it is
1.
1. We'll deal with it same as what we deal with empty set. Now, the other two questions I need you guys to answer. What is 0, epsilon 1? What is epsilon 0, epsilon 1? I need you to answer these two questions.
So, Professor, are the solutions going to be posted later, like after we submit?
Yeah, tomorrow
reviewing?
after class, I will post the links for the 3 videos. And I will post the link for the shared Google Drive folder that you can put your sheets.
Okay, thanks.
Sorry, can you post the questions as well?
Yeah,
separate?
I will mention that the question in slide number XYZ.
Perfect. Thank you.
So it will be clearer for you guys. So our last slide for today, what do we mean by powers of alphabet, which is alphabet to the power of k, is the set of strings of length k, a set of strings of length k. So when we see alphabet to the power 0, that contain epsilon. Alphabet to the power 1, that means 0 and 1. Alphabet to the power 2, that means also this question needs an answer. You can use either numbers or digit or any character to answer your question. Okay, guys? And we have the symbol called clean star, alphabet to the power of star, which means the union of alphabet of 0, alphabet of 1, alphabet of 2. For alphabet 0 and 1, what is the clean star? This question needs to be answered. Fact, although clean star is infinite, all elements of clean star have a finite length. So remember this fact. We will stop here at the slide number 17 for today. Okay.
Is there a specific number that you'd like us to get to for the clean star? Because it, like, is there a stopping
you have
point?
to think about it. You have to think about it. We have 2 symbols.
Right.
Think about it, okay?
Also,
It is
since I
simple,
wasn't
but
due
I need
dates,
you guys to search and understand what do we mean by clean star, what do we mean by the power set. You're supposed to take, you know, based on the recommendation when they give me the course from the university, that this information is should be ready, or students, they are ready for this one. However, it is very important to refresh your mind. I understand that. And maybe some students from overseas, they don't have these topics before. So if you have any difficulty, get back to me on next Wednesday office hour. You can ask anything you need. Or if that time is not fit your needs, or it has a conflict with some other thing, you just email me and we can arrange for any time to have a Zoom meeting. Okay, guys?
I have a quick question about the empty string, if that's all right.
Yep.
So you said the size of the empty string is 1 in the alphabets and string slide.
Here?
No, not the empty set, the empty string.
Oh, the epsilon, yeah.
So if you take the size of an empty set, it's 0. So why does it change? The reason it was 1 before was because it was a set containing the empty set. But in this one, it's just the empty string itself. So why is it 1 and not 0?
It is not 0 because we consider it same as what we consider in the set theory. Okay, so we have an empty string. So there is a one string with no letters in it.
Okay, so you just treat the string itself as a set. So it's a
Yes.
set containing no, okay, all right, thank you.
You are welcome. Any other
So I have
question, guys?
I have a question about the functions. If you can go back to that slide.
Yes.
Yeah. So the final one, if you just press enter. Yeah. So the final one, the multiple. Can you go after that? Next one.
This is alphabet and the string.
Oh, sorry. Go to the domain and the image and
Yeah, here.
yeah. So for the image is n to the power 0, example 0. Can you explain this part? Like
This one?
what's happening? Yeah, this one.
Okay. So when we said x will, if we input x, we'll have an output of x squared, right?
Mhm.
So if we enter any minus number, -1, -2, -1 million, -2 squared will be +4, right?
Yeah.
Because any minus number or negative number, if we square it, we will have a positive output, right?
Mhm.
And since we are saying that x belongs to z, which is the integer, so the 0 is included, right?
Yes.
From -infinity to +infinity, and the 0 in between. So if we have 0 square, what that will take us to as an output? 0. So any output from -infinity to +infinity, it will be either 0 if we have the 0 as an input, or it will be a positive number. So we'll have the natural number union with the subset 0, right?
Yeah.
In this case, in order to make things simplify, we call it natural number and to the power 0. That means the 0 is included in this set of output. So this will be the image of that function, which is where the output will be belong to, which set or subset that the output will be belong to.
Okay, makes sense now. Thank you.
Okay. Any other question, guys?
Sorry, so in this case, what would the codomain of like the first example be? Because you said it was a typo, right? So you say the domain is the set of all integers, but what would the codomain of this example be?
Okay. So the codomain is a set as a set B. It is the same, into which all of output fall. So if we said that Z, so we will put the codomain is Z, where you have to put the condition that x or x squared is 0 or greater than or greater or equal to 0. This is the codomain.
Okay.
Did you get the point?
So in other words, yeah, no, I forgot.
So,
I didn't really read the.
You know, literally, if you think deeply, the codomain and the image will guide you to the same answer.
Yeah, I didn't fully read that. Like it was used to express the range as well. Yeah, my bad.
Yeah. Any other question, guys?
Yeah, I just had one more question.
Oh, sorry. Yeah, go ahead.
In one of the earlier slides, we were talking about x1 being an element of A or not being an element of A. Can you go over the difference between a subset and a proper subset again?
Here?
I think it was one up. Yeah, those two at the bottom. So
Yeah.
you said both of those were true, but I don't understand how. Yeah, is that because that would not be a proper subset of A, right?
In set theory, that there is a rule saying that each set is a subset of itself.
Right. So the second one would be true, but it
And
wouldn't
the
be a proper subset.
The first one is true, but more formally, mathematically, the second one are more formal. Did you get my point?
Not really. So I understand that a set is a subset.
Wait. If I'm saying each set is a subset of itself, so the first one is a true or false?
Well, the first one's a proper subset, right?
Here?
Yeah.
Okay,
sorry, no,
here
that's-
we are talking about set theory. When we're saying each set is a subset of itself,
Yeah, that makes sense.
this is true. And each set is a subset or equal to itself. It is the same. But which one more formally in mathematics? The second one. But both are true. So in the exam, if you didn't put equal for me, I'll not put wrong for you.
Okay.
I will not deduct mark. But more formally, the second one, it makes sense more. Okay?
Yep. Thanks.
You are welcome. Trevor, do you have a question?
I actually had the same question, so that helps. Yeah, thank you.
Okay, you are welcome. Other question, guys?
When are you going to be posting the slides and the lecture recording?
The slides already posted since last week. It is in OWL in the resources tab. Are you added to OWL or you joined the class later, but you should have an access to OWL? Hello? Hello?
I have access to OWL, yeah.
You have an access to OWL, to the course website? Okay,
Yes.
let me show you here. I'll share the screen. Here our course website. If you go to the resources, but here, okay, let me get student view. Okay, if you go to week 1, you will have the handout here. Okay.
Yeah, I found it, thanks.
Okay, you are welcome. Any other question, guys?
Professor, one final question.
Yeah.
So for the subset, the first one, where's the x1?
If it has a real root, so that one is for one unique solution, right?
Here?
Yeah.
Are you
so the
talking
first
here
one,
or before?
Yeah, so the first one from here and the first one from the top, the set membership. Can you compare both of these two? Because I feel they are the same. Like, what does x1, does it say just x1 is inside?
Yeah. Here we're saying x1 belongs to B, which means x1 is an element of the set B. So is it a member of the set B? This is the symbol name means belong to. So we are not talking about subsets here. We're talking about element, and we're saying what are these set members. So I will say B has 3 members, x4, x5, and x6. So if we write x4 belong to B, true, x5 belong to B, true, and x6 belong to B, true. But is x1 belong to B or a member of B?
That's wrong.
This is false. X1 is not belong to B, that's true. Here we are talking about a subset because each set can be consist of single individual element of that set or any combination of 2 up to all elements. So each set could be considered as element if the size of the set is 4. So we can have any subset that consists of 1 element, 2 elements, 3 elements, and 4 elements, which is the subset or the set itself. So each set is a subset of itself. Is that clear?
Yeah, so in the first case, the set membership, if you have x1 and x2 at the same time, there's going to be.
We cannot say belong to B. This is a subset. So we'll say it is contained in A. When we're talking about belong, it should be one element.
One element.
I cannot say x1, x2 belong to B. No.
Oh, okay. Okay.
The subset x1 and x2 are contained in A.
For the first three subsets, don't they need curly brackets in order to be true?
Which one? Here?
Yes, those three.
Yes, you are correct.
So are those first three false or correct?
Yeah, in current situation, they are false.
Ah, okay.
But if we put a bracket, they are true.
True. Okay, thank you.
You know, we will have a lot of typos in the slides, but it's not my slides. And I've been advised by the department administration that try to use the same slide because Dr. Essex in the coming, I don't think next year, the year after, will back to teach this course. So that's why there are some typos we can consider. Sorry for this one, I missed to mention this. So the subset, it should have brackets. In this current situation, they are false all. This one, those are true, both. I will mention that in the announcement. Thank you for raising this issue. Other question, guys? Those who don't have a question, you can leave. Those who have a question, you can stay. And I'm happy to, more than happy to answer all questions.
I just wanted to ask, so did you post like a document with all of the questions we need to do, or are you just going to do that later?
Yeah. And when I make the announcement to the Google Drive, I will make an announcement. These questions need to be answered. For example, what are the answer of the questions in this one? In slide 14, what is the power of A? All of these things, I will mention what need to be answered.
All right, thank you.
You are welcome.
When should we hand it in by?
You have, you know, before, like when I deliver this today, before the coming class on Thursday, you need to handle it.
Okay, thank you.
And always I'm flexible till the end of the class time. So next class, I will remind the student, for those you have till the end of the class time to hand your answers.
And this is for bonus marks, right?
Yes.
Okay.
Sorry, I went to the wrong link and I showed up late to class. Can you clarify like what you're talking about in terms of like the first half? Is there like a quiz or something we have to do?
No. So these are bonus questions. And I will put a shared folder in Google Drive. So you can put your answer. You need to write in the paper your name and your ID in the top of the paper. So these questions normally like any class exercises or practice. These questions, the total of these activities will weight 5 marks for bonus to fulfill any gap in your assignment or quizzes.
Okay, thank you.
Yeah, but for the quizzes, I don't have like unannounced quizzes. Always will be announced at least 1 to 2 weeks before. And all quizzes, I'll consider all accommodation timing. So some students need like for each hour 40 minutes. Our quizzes maximum will need an answer of, I'm not sure, 20 minutes maximum. Normally my quiz is between 10 to 15 minutes. So if I have a longer quiz, it will be 20 minutes. I will put a 45 minutes, more than 100% of the original quiz time or required time. So all students will have more than enough time to answer the quizzes, even those who has accommodation that they need an extra time to answer their, let's say, examination. It's a quizzes, not exams. Question, guys?
This is a scheduling question. I'm trying to remember from.
Hello, I cannot hear you. Your voice gone. Hello. Hello. Who was asking, Chris or Muhammad Ali?
I think it was Chris.
Okay, Chris, can you hear me, Chris? Seems he has a problem with his mic. You can email me your question, Chris, if you have an issue with mic. Hello, Chris.
Sorry, can we go back to epsilon for a second? I had a question about its cardinality.
Cardinality?
Yeah, of epsilon. So the empty string. So isn't the cardinality of the empty string 0?
No, 1.
So I just have a question.
We will consider that there is in this tuple or in this alphabet a string that contain no character.
Right. But that would be like if the set contained epsilon, but the cardinality of epsilon itself would be similar to like the empty set, right? Because the cardinality of the empty set
it will be like the empty set, which is 1, yeah.
But the empty set by itself, like I would agree that it's 1 if there's curly braces around epsilon, but epsilon itself should have a cardinality of 0.
Turing machine and when we go to regular expression and irregular expression, you will understand what do we mean by epsilon. But any cardinality for epsilon is 1, for infinity is 1, or for phi is 1. It's considered as 1 element.
But that's if it's contained in its own set. Like the cardinality of epsilon by itself
we will start using like epsilon and phi in some computation set, like a separator, like the starting of the string, end of the string symbol, that for the computer to understand that we stop here. So it is considered as 1 element.
Right, if it's contained in a set, no?
Yeah.
Like, but I mean this expression right here, so like what is the cardinality of epsilon by itself, not contained into a set, would work out to be
1.
0.
Check it and I will check it back, but what I know and what we work is 1. But for itself, we will check.
Okay, because I mean there's a link on the slide that says that it's 0. Yes.
Oh, the string length. Okay. But if it's
I guess that part's confusing.
If it's in between a bracket, it will be 1. Yeah.
Yeah. If it's in between brackets, it'll be 1. Yeah.
Okay.
Okay. Thank you.
You're welcome. And the phi will be the same.
Yeah. Phi would be the same.
Phi
so in the power set.
Yeah.
Yeah. In the power set it acts as a set, but within phi by itself, it should be 0.
Okay. So with this bracket, it will be okay. Okay.
Yeah.
So we are talking about string. So if it's but later on, Liam, when we're talking about the Turing machine, you will find the epsilon is counted. It will take we'll make 1 empty slot of memory.
Right, because like epsilon denotes like some other representation, right?
Yeah, it means an empty cell in the memory.
Yeah, it's like a placeholder.
That's why we will consider, like, we will skip 1 memory cell to let the computer, because the computer is machine. It has no thinking capabilities. We are thinking and we instruct the computer, do this, he will do that. The computer will do that or the programming languages. So you will use some empty. For example, in binary, later on, if you go for your graduate studies, you will, and you work with these things and processor think with machine language. For example, negative number, how we will let the processor know that it's negative number. Some processor will use a 1 at the beginning of number or a 0. This one is not counted as part of the code or of the number, but this will give it as a positive or negative.
Okay.
Because we need
I guess that makes
something
sense.
or some flag to make the computer understand what we are going to do or what we are doing.
And so when we denote that mathematically, we just use epsilon as like
normally, for example, for empty memory cell, we'll put epsilon. That's it's a skipped memory that has no character or digit.
And so like when we represent like, I guess, high level, like hardware implementations using like the different flags, I guess you represent that mathematically as epsilon.
If you take, if you study, I'm not thinking, I don't think that you're.
Yeah, I'm in computer engineering.
The whole program has, do you have a computer architecture course?
Yeah, I'm in computer eng, so this is like an elective for me. So I've studied
okay. So in the computer architecture, you know the flags and registers.
Yeah.
So or flip-flop. Sometimes we use those, and we put like a flag to let the computer understand if this is 0, that means X positive. If this is 1, that means negative. You know, you understand, since you are in computer engineering, you'll understand this more. And also these will be reflected in the operating system.
Yeah, and so that's just like a mathematical representation for like your different set architecture, your instruction set architecture, right?
Yes. Yes.
And so like I've been through
this course, we go to the low level, how we build the programming languages. If you are in computer science, this course is a prerequisite for a compiler design and implementation course.
Right. Yeah. Yeah, I've looked at that kind of stuff, like different parse trees and stuff.
Yeah, for lexicon and parser, exactly.
Yeah, going further down in the slides, like we start looking at these different like finite state machines that are somewhat different from like some of the state machines like I'm used to seeing. I just had like some questions on how those work, because like I've worked with a friend on something like similar to that for one of his courses. And it seems like they get pretty complex with like accepting states and like different states like that.
Yeah, so, here we will start. What do we mean by deterministic finite automata, which mean here we will do a finite machine. And this graph theory will let you understand how we will represent this alphabet.
Yeah.
And here we'll go to the table. So we have deterministic, non-deterministic, regular expression, irregular expression, Turing machine, which is one of the most interesting topic in this course.
Right. Okay. What else do we get into this course? Because I remember doing something where it was like a loop invariance, if you know what that is, where it's like you come up with mathematical equations.
We'll touch base with some recursive.
Okay.
Yeah, because you know it's the fundamentals of this course. I cannot go high advanced.
Right.
Yeah, and you know the time limit, it's a 12-week. I cannot cover the whole book.
Yeah,
and you know there is a reading week in between and all of these stuff. So yeah, but you will have a good idea. We will have the computational complexity in terms of finite machine. If the problem is NP hard or NP soft, all of these things, and what do we mean by the decidability? Is this problem decidable, not decidable? Is this language decidable or not decidable? It's an interesting course, but at the end point, but we cannot go very deep in these topics. But it will give you the sense. So if you took any other extra course, especially for computer engineers, you will see, oh, this is how it goes.
Okay, that makes sense.
Yeah.
Makes sense. But this is like the mathematical representation of it, right? Not
yes, it is a graph theory. Basically, this course will represent how we do the programming languages, how we think about code, like if statement or for loop, how the compiler will read and understand it in terms of a graph theory.
That makes sense. Yeah. And so it's what? It's 4 assignments, 4 quizzes, and then one final paper? Okay.
Yeah, is there like the final term paper, you know, in this course it's difficult to give you a project. So it will be a topic of the course. We will start from chapter 3. So next week I'll make a Google sheet to put the groups, However, I'm still waiting the adding time to be done by the end of this week. So as of next week, I will add an Excel sheet. We till the moment last year I have 90 students. This year till the moment 152. So it also I'm thinking to make the assignment as a group also, but the group project will be larger in order to have enough time for a presentation. So it will be larger than the group one. For the group one, I believe 2 to 3 students per group for the assignments.
Okay.
And,
okay, that makes sense.
Yeah, and for the term paper and the group presentation, that will be 5 to 6 students in the group, because I cannot kill the TA and marking all of these things. I have to think about them. I used to be a PhD student and I work as TA. I'm feeling with them. So
yeah, so the assignments, are they programming languages or are they like written?
No. It is a set theory and.
So it's theory.
Yes, set theory mainly for the drawing. You will do it by your hand. No need to do it by computer. If you do it by computer, it's your call. And other question could be typed, or the other question or the essay question or the proof question should be typed.
Okay. And are the quizzes also going to be like written that way? Like you write it, you scan it, upload
the quizzes will be offered in OWL. So in OWL, you will have 2 parts of the quiz, 5 questions of multiple choice or quick answers, and 1 or 2 questions that you need to write your opinion or your reasoning for a problem. This question will be checked by Turnitin. So it will be your original answer and your wording. So to understand that problem.
Yeah, okay, that makes sense. Do you have a schedule in mind for like the quizzes and the assignments, or?
Yeah, normally like
once a week.
Once we finish the 3rd handout, we'll have the first assignment, and the week after the first quiz.
Okay.
Normally, before the deadline of that assignment, you will have a tutorial session that will solve some question, answer your question for the assignment. That will help you for the assignment, and for sure this will help you for a quiz. Normally the quiz after the deadline of the assignment. So you will study for both in your assignment and the quiz. And I don't want to like overwhelm students in studying at the same time for both tasks.
Okay.
So normally, like after that, maybe every 2 weeks we'll have something.
Okay, perfect. Well, thank you very much.
When I announce the assignment, at least you will have 2 weeks to solve the assignment, which is more than enough.
Okay.
My assignment is not harsh and not difficult. Yeah, don't worry.
Okay, nice.
I'm trying to help all student guys.
Yeah, perfect. Okay, thank you very much.
See you tomorrow.
Yeah. Okay, have a good night.
Tomorrow. And have a good night, guys. And see you tomorrow. Bye.